Yes, sir.
Yes,
Also
sir.
the number of fringe
How
shifting.
the shifting happens? How does the interference affect? Whether will there be interference or not? All that we saw. Yeah, am I correct? Is
Yes,
it
sir.
so, Harsh? सो गया क्या? हर्ष क्या हो
हाँ
गया?
सर.
हर्ष अरे बोल, बात कर.
अरे हेलो
So today's class, what we are going to learn?
हेलो हेलो सर.
I can't hear you, Harsh. Your voice is very feeble. Can you say mic testing? Hello, hello, 1, 2, 3.
हेलो 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 हेलो.
Your voice is feeble. I can hear you, but your voice is feeble. Am I correct? No, his voice is audible very less. No.
Yes,
Okay.
sir.
I think polarization is not available in your syllabus. Is it so, Caroline? Can you confirm?
Yes, sir.
So so this is the last class. Then diffraction is the last class. Diffraction is the last class. Am I correct? The last topic of this chapter. Is it so? All of you?
Yes
Yes?
yes sir.
Yeah. Okay. So hear me out. So today we are going to learn diffraction. What is diffraction? If somebody asks you why diffraction, what is the basic definition? What is the basic definition? What is diffraction? Yep. Caroline, what is diffraction? Studied in school already. What is diffraction?
Diffraction is when a wave has an obstacle.
It
It
is
occurs.
a phenomenon occurs when a light due to bending of light across the corner of a obstacle, basically small aperture, okay, forming geometrical figures. Am I correct? So basically what is this? This is a phenomenon. Geometrical figures are happen. So you saw till now the interference are what? Alternate bright and dark fringes. Am I correct?
Yes, sir.
Alternate bright and dark fringes. So let's say this is center maxima. Center maxima. This is 1B, 2B, 3B, 4B. Similarly, but you see, what did you see? You see that all the intensity are same. Intensity do not vary for interference. Remember that. Interference do not vary. Okay. Interference of all bright fringes are same. Means whatever intensity is for 1B, same for 2B, same for 3B, same for central maxima, and 1B for other side. But this is also a geometrical pattern. These are alternate bright and dark fringes with same intensity. If it is dark, it is completely dark. I equal to 0. If it is bright, it is I. This is I. It is not that I1, I2. Clear? But what about diffraction? Diffraction is what? It is a geometrical pattern, but how it happens, you know? It happens like this. Middle one is high. Okay. The side ones are low. Again, this is 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 low. And again, this is low. So what do you see? The brightest fringe is what? The middle one. Central maxima. Central maxima is the brightest fringe. These two are again equal. These two are again equal. These two are again equal. Are you able to understand, guys? Guys, are you able
Yes,
to
sir.
understand? So in
Yes, sir.
diffraction, you don't have every bright fringe to be same intensity. Alternate here, central maxima is the highest. Then you see it is second highest. Then again it is third highest. Again it is fourth highest. So it is like, so these two fringes are equal. That means 1B and 1B, both sides are equal. 2B and 2B are equal. 3B and 3B are equal. And it is basically like you can treat whatever. So are you clear on this, everybody?
Yes, sir.
Yes, sir.
This is a major difference between the diffraction and interference. So never say that diffraction and interference are same. No, it is not same. Okay. So let us see some observation. Let us see. So this
Sir?
was yeah.
Sir, can you repeat the definition of diffraction?
Diffraction is the phenomenon. The occurs. Phenomenon occurs due to bending of light across the phenomenon occurs when a wave, write properly, when a wave encounters an obstacle or an opening. When an obstacle or wave encounters an obstacle or an opening. It is also defined. It is also defined bending of waves around the corners of an aperture. Bending of waves across the corners of an aperture, forming geometrical patterns of shadows and bright fringes, whatever you can say, but forming geometrical pattern.
Okay, sir.
Is it clear, all of you?
Yes, sir.
Advait?
Yes, sir.
Yes, sir.
Okay. So now we will see some observation. I have a slit. Okay. I have a slit S1 and S2. I have a screen here. Okay. I am, light is coming like this. Light is coming like this. Okay. So what do you expect? Ideally, what you should expect? Only the light will fall here and light will fall here. Yes or no? What about this place? This place should be what? Dark. Am I correct? Yes or no?
Yes, yes, sir.
But does this happen like that? No, it will not happen. How it will happen, you know? If you have slit like this, light is not treated anymore as to be straight line, because Huygens principles say that light is no more straight. It travels like a wavelets in all direction. That means if it is a wavelet, here let me introduce this as a wavelet, point from here, light is not only going like this, light is also going like this. So similarly from here when the light goes, so no more you will get dark shadow here. Rather, you will get some value, some intensity, maybe it's very minimal intensity. Comparing to this place, you might get a lesser intensity, or maybe very simply, you will not get dark shadow. You will only get dark shadow if you consider light to be a straight line, but light is no more a straight line, because these are very small slits, and we know that the width of the slit is equal to the comparable to the wavelength of the light. Am I right? Yes or no? And also we know that your d has to be greater than small d, then only these things are. So ideally, by Huygens principle, it is clear that light will not travel in straight line. Rather, each primary also give rise to secondary wavelets. Again, this point will again act as a secondary wavelet. This point again act as a secondary wavelet. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
Okay. So ideally, what is happening? light is bending. See, which is supposed to come like this, it is bending. That means this is an aperture. This is basically obstacle. It is bending. This is what I'm trying to explain. Am I clear? Am I clear?
Yes, sir.
Let's see observation 2. Let's see second observation. You have an obstacle here. Okay. Pardon with me, I'm just having my this thing. Tea and this thing. So light is, this is a source, so light will go in all direction. Light also come in this direction. Now, when you have a screen here, so ideally what you should get, you should directly get a shadow here. Am I right? Yes or no? Yes?
Yes, sir.
Because light will go
Yes,
straight
sir.
line. This will block, but no, it is not like that. It will basically what will happen? The light shadow will be somewhere down. Shadow will be somewhere down. That means light will actually fall here. That means there will be bending. So here shadow will be, this block will be shifted downwards. Okay. Am I correct? And this whole part will be the illuminated region. This will be a shadow region and this part will be illuminated region. In both the example, what did you see? It is clear that light is no more traveling in a straight line. Rather, light is bending across the corners of the obstacle. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
Yes,
All of
sir.
you? Okay,
Yes, sir.
fine. Observation 3. I have a small aperture, chota aperture. This is a small hole, pinhole camera, and I am putting a light source. So ideally, what you should expect, you will expect a hole to be this big. Am I correct or not? Yes.
Yes, sir.
Yes,
This
sir.
type of phenomenon happens when, remember, lunar eclipse. I don't remember here. Lunar or solar eclipse. Yes or no? Do you remember this type of occurs when light, sun will be behind, moon will be between, something like that.
Yes, sir.
Yes or no? So ideally, this
Solar eclipse, sir.
solar eclipse. So normally this part will be what? This whole part will be bright and other part will be shadow. The whole part will be bright. Okay. This is the actual what? Actual expectation, but it will not happen. What it will give? I will tell you how it will be. This will happen like this. Middle one will be the brightest. Okay. Brightest. There it will be second brightest. Again, third brightest. Means third less brightest. Fourth less. That means the middle one is the central maxima. Second one is the 1B, 2B, 3B. So that means more and more we go, it becomes what? Less and less intensity. And then it is complete shadow. So basically your intensity decreases once you go from the center to the ends. Am I clear till now?
Yes, sir.
All
Yes,
of you?
sir.
Yes, sir.
Carlin, clear, no?
Yes, sir.
Intensity gradually decreases once you go away the center. You more and more you go, this becomes more and more darker. So maximum you can see until maybe 2-3 fringes or 4 fringes. Probably you will not be able to see because your eyes will not be able to see so lesser intensities. Am I clear? Yeah.
Yes, sir.
Yes, sir.
Now let us go to observation 4. Let us go to observation 4. Now we will talk about the single slit diffraction. Is it there in the chapter? Single slit or double slit? What is available in
Double slit, sir.
Double slit interference is there. Single slit diffraction is there. Can you check properly?
हाँ सर, हाँ सॉरी सर, सिंगल स्लिप सर.
मार खाएगा. तेरे को खुद नहीं पता क्या है क्या नहीं. What about Caroline? What is the new syllabus? Caroline, what is the new syllabus?
So 1 minute, sir. I check, sir.
Yeah.
Sir, you proceed, sir. I'll check later,
Yeah.
sir. It will
Okay.
take time.
It will be single slit only. You don't have double slit. Okay. So now observation 4. You have a screen again. Okay. Light is coming here. But I told you light will bend. Light will bend. And what is happening? Here, this place is a central maxima. Is a central maxima. And here, when the light comes here, this will form, what is this? 1B. Am I correct? This will be 2B. This will be 3B. This will be 4B. This will be 5B. Similarly, the same thing will happen here. So can you see the difference? Here also you have alternate bright and dark fringes. But the middle one, that is the central maxima, is the brightest. This place is the brightest. Okay. But at the other two ends, I mean the both ends, you see the intensity is what? Decreasing or not? Decreasing or not? So if I consider this to be central maxima, the intensity is decreasing. That means only at the center it is maximum intensity, because the path difference is 0. The path difference is 0 here. Rest, we'll come to that. Rest, everywhere that there is a path difference, significant path difference, it is same. Till now it is clear or not?
Yes, sir.
Yes sir.
Yes, sir.
Clear? Okay, now we'll
Yes,
come
sir.
to the normal derivation, like how we did for interference. Okay, so let us have again this one. You will have again your screen. So let me 1 minute. I'm just showing as a big, but actually it's not bigger. Hello. Yes. Yes, either tell me. Yeah. Mm-hmm. Mm-hmm. Approval is pending with whom? So clear? So this is the basically the length of the slit is A. Okay. So here we are not talking about any difference. We are only talking about the width of the slit. And this is forming 1D here, dark, and here again 1D. And middle you have central maxima. Okay. So the length between the 1D to the central maxima is lambda by A. And similarly, the length between this one is lambda by A. We'll see how it happens. I'll tell you. Similarly, this is A, this is theta, the angle between the line between the center and the from the center to the 1D, this is theta. So when this is theta, so this becomes A sine theta. This is the maximum. That means this ray, this wave is traveling more distance, like how we saw in interference. So if I want to find out the extra length, extra distance which is covered, this is actually the path difference. Am I clear? Okay.
Yes, sir.
Yes, okay, sir.
Already we discussed, so I don't want to go ahead how it happens. That you can see the earlier video. I don't want to tell how it happened, that you already know. Okay, I don't want to explain that again and waste time. So your 1D across occurs when delta x is equal to lambda. That means this one 1D happen when delta x is equal to lambda, that this much length. What is delta x here? Delta x, the extra part difference is what? A sine theta. Am I correct? That means A sine theta is equal to lambda. Then what is sine theta? Lambda by A. Am I clear? Am I clear?
Yes,
So
sir.
already we did the assumption sine theta is very small. Then sine theta is equal to also theta, which is also equal to tan theta. Yes or no? When theta is very small, sine theta, tan theta can be equated. Am I correct? Yes or no?
Yes,
Yes,
sir.
sir.
Then your tan theta will be equal to lambda by A, by this one. So this is how you have to explain. You have to tell theta is very small. Then sine theta can be equated to tan theta. Hence, rewriting sine theta equal to lambda by A is equal to tan theta equal to lambda by A. But what was tan theta? Remember the interference. What was tan theta? What was tan theta? Tan theta was y by d. Yes or no? What was tan theta? This one, this figure. Remember, this is y. This part is y. This part is, the length is how much? What is the distance between the slit and the screen? D or not? So tan theta is perpendicular by base. So y by d. So y by d is equal to lambda by A. Am I correct? Am I correct?
Yes, sir.
Yes, sir.
And what is your y? Your y becomes d lambda by A. So what is this? This is y1d. Am I correct? So your 1d happens for 1 lambda. So similarly, what about your 2d? Your 2d will happen when delta x equal to 2 lambda. So what is your general formula? Your general formula will become ynd is equal to nd lambda by A. Pretty similar to interference. Am I, yes or no?
Yes, sir.
Am I correct? All of you?
Yes.
This is about what? Bright fringes. Or that this is not this is dark. No, we are talking about dark, not 1D. Sorry, not bright. It is dark. So dark fringes happens whenever delta x is n lambda. That means 1 lambda, 2 lambda, 3 lambda, 4 lambda. Am I correct? Yes.
Yes, sir.
Clear?
Yes, sir.
Now we'll go to bright. So bright, what happens? Caroline, what about bright? Any idea? You tell me. What about bright? Who will be able to tell me bright? How the bright happens? See, initially what I told you, that this is a bright maxima. Okay, this is the second bright. Sorry, not like that. So this is one bright. This is one bright. Am I correct? Yes. Yes.
Yes, sir.
And
Yes,
this
sir.
is, what about this one? This will be 1D. Yes or no?
Yes,
What
sir.
about here? It will be 2B. So what about this one? This was also 2D or not?
2D.
So we know 1D, we know 2D. So what about this one? It is simple here. This is 1, this is 3. So how do we find 2? We can do 1 plus 3 by 2 or not? That is equal to 4 by 2 equal to 2. So if you want to find the middle one, so how do we find? You just sum it and then add it and divide it. Am I correct? Already did in school. If you want to find between numbers, if you know there is a value 0.1 and there is a value 0.15. So if you want to find a value between them, what do? You add both and then divide by 2. Yes or no?
Yes, sir.
Yes
Yes,
or
sir.
no? So similarly, you know 1D. What is 1D formula? Your 1D formula is d lambda by a. You know 2D. What is 2D? 2D is 2d lambda by a. Then can we find 1b? How? Your y1b becomes how much? 2d lambda by a plus d lambda by a divided by 2. That's it. Yes or no? Yes or no?
Yes, sir.
Yes,
Clear?
sir.
No? Easy? No? Then what you will get? What you will get as first 1b? What you will get? So 2 plus 1 is 3. So what is your answer? 3 by 2 d lambda by a.
A.
A or 2A? Can you check properly? I think we'll get 2A, not will you get, yeah, sorry. 3 by 3 3 by 2 d lambda by A. Or else you can write as 3d lambda by 2A. Is it clear, all of you? Is
Yes,
it
sir.
Yes,
clear?
sir.
Similarly, if I ask you to find out, what about others? Find about what is y2b, what is y3b, what is y5b.
Multiple.
Will you able to tell? Will you able to tell?
3D lambda by A.
Same formula, 2n minus 1 d lambda by 2a. So what difference do you find? Who will be able to tell me what difference do you find? Your dark and bright formulas are changed. That means, if you remember now, in interference and your diffraction, if this is your bright and this is your dark, for bright the value was YNB equal to ND lambda by small d for bright here. So this formula is applicable for dark, that is YNB is equal to ND lambda by A. For dark, for interference, your YND was what? 2n minus 1 into d lambda by d. So here this got changed here. YNB equal to ND lambda, sorry, dark. No. Here, sorry, 2n minus 1 d lambda by 2. Clear, all of you?
Yes, sir.
Easy or not?
Yes, sir.
Yes, sir.
That
Yes, sir.
means the D, so simple. Remember, if D is there, so here what is D? D is for interference. And what is D? D is the distance between this slit and between this slit. This distance basically. What about A? A is the width of the slit. This is A. Am I clear? Or else your D remains same. Everything remains same. So whatever is formula is for D, that will applicable for B. Whatever is for B will applicable for D. Clear?
Yes, sir.
No doubts? No
No,
doubts?
sir.
No, sir.
Okay. So what about central? Now tell me what we saw. We saw that 1D, this is 1D, and again this side is again 1D. So the distance between the here to here is how much? Lambda by A. Distance between here to here is how much? Lambda by A. That means what is the, so basically if I see, you see like this, it will be like this. So 1D happens where? Here. So distance, so this is the center. So basically try to compare with a screen. So this is the center. So if the distance between here to here is lambda by A, so which I am talking about this length. So distance between this and this is lambda by A, which I am talking about this length. So if I want to tell you what is the width of the bright fringe, so what is the total distance or not? Yes or no? If this is lambda by A, if this is lambda by A, so what is the width of this one? What is this width? 2 lambda by A. Am I correct?
Yes, sir.
Yes, sir.
That means the width of the central bright fringe is 2 lambda by A. How? Already told you. Because this is dark fringe. So dark is here. Dark happens at, from here to here it is lambda by A. So till from here to here lambda by A, here to here lambda by A. So the total is lambda by A plus lambda by A, that is 2 lambda by A. So this is the width of central bright fringe. Am I correct?
Yes, sir.
Yes, sir.
Very clear. Very
Yes,
clear.
sir.
Okay.
Yes, sir.
So now if you plot a intensity versus theta, I versus theta, that how the intensity is decreasing. So how it will be beautiful, it will be. So here it will be what? Theta will be, what will be theta? Theta will be 0. Delta x is 0. A sin theta 0. When A sin theta 0, sin theta 0. When A sin theta 0, when theta is 0. Am I clear?
Yes, sir.
Yes, sir.
Here what is the value of theta? What is theta here? Delta x here. Delta x is A sin theta. Yes or no? So A sin theta is what? Lambda. Am I correct? So can I say here theta is lambda by A? Can I say?
Yes, sir.
If you consider A to be 1, so can I say it is lambda? So here it should be 2 lambda. Again here it is lambda. Here it is 2 lambda. If this is lambda, this is 2 lambda. What about this one? 3 lambda by 2. See, here again it will be 3 lambda by 2. This will be 3 lambda again. So what about here? It will be 5 lambda by 2. Here it will be again 5 lambda by 2. Here again 3 lambda by 2. Am I correct? Am I correct?
Yes, sir.
All of you clear? All of you clear? Any doubts?
No, sir.
Sir.
Yeah, Siddhi. Any doubts? Any doubts?
Sir, why lambda, like it will be lambda by 2.
Which one? Which one, beta?
The first one,
For why lambda by 2?
after the 0.
What is delta x? Delta x equal to lambda. This is for 1D. Yes? So delta x is what? A sin theta. A
Yes,
sin
sir.
theta is lambda. So if I am telling A is 1, so
Yes,
can I
sir.
say sin theta lambda? So if sin theta lambda, theta is also lambda,
Yes,
no?
sir.
Because I am considering theta should be equal to sin theta. I am equating with theta, no? Add smaller value of theta, sin theta is equal to theta. So if sin theta is lambda, so can I say theta to be lambda? Am I clear?
Yes, sir. Yes, sir.
All of you clear, no?
Yes, sir.
Yes, sir.
Please rejoin back.